Right. F of x. Let's see, like, do a weird one, an exponential one. F of x equals e to the x after the following transformations. I don't know why my computer is so slow. That's okay. We'll wait for it to finish writing. So we're actually going to do 5 things to this function. We're going to reflect it over the x-axis. We're going to do a vertical stretch. By 3. We're going to do a horizontal shrink by 1/3. We're going to shift it right 2. And we're going to shift it up 4. Okay, so we have lots of things happening here. So I'm going to go through them like one by one. Reflect over the x-axis, right? The x-axis is down here, so if I'm flipping over it, I'm flipping vertically. So that's outside of my function, right? So reflecting always puts a negative outside of my function. The next thing we're doing is vertically stretching by 3. Again, vertical stretch means it's outside of my function. Again, things vertically are outside, and it's exactly what it is. So 3 is just going to stay as a 3. The next one, horizontal shrink by 1/3. Again, it's horizontal, so it's happening inside of my function. So I'm going to write that f of, right? So this is going to be inside those parentheses. And since it's inside their parentheses, remember, it's flipping. So shrink by 1/3, well, I have to flip that. So really, that's going to be a 3. If I flip 1/3, I get 3. So 3x and then I'm going to shift it right to again, right is horizontal, so that's still inside my function, inside my parentheses. And since it's inside, it's opposite. So right is usually this way, positive numbers. But since it's opposite, we're going to flip it to do -2. And then finally, we're going to shift up 4. Okay? Shift up is outside of our parentheses, so I closed them already. And since it's outside, we don't have to flip it, so it's still just +4. Now I just have to actually write this with my function, right? My f of x is actually this e to the x. So this is going to equal, that's just going to be still -3. I'm going to replace like my f of with the function. So my function is this e to the, everything inside the parentheses is now where my x was, right? So and if you want, for exponential, you don't really need parentheses, but if it helps you to know that that whole piece is in your exponent, that's fine. And then +4 comes back down. No? Okay, so this is kind of what we've done in all our other examples, but like we have to just put it all together. And they really don't affect one another. Right? So like just because there's a 3 here doesn't affect anything else necessarily when we see like a whole function. So really as you're reading it, you're just doing each piece by piece as you go through. Okay. The next thing we're going to look at is graphing these functions after their transformations. So example 5, and for each of these, we want to know what the parent function is. We want to know what that transformation is, and then we want to graph it. So looking at A, we have g of x equals x squared minus 1. The first thing I want to know is what is my parent function? It has that squared, so I know this is squaring. Or you could call it quadratic. That's fine too. I'm fine with either of those. So I'm just going to start by graphing actually that parent function. So there it is. It's beautiful, right? We should know how to like sketch the graph without really just like from memory, right? We should have these kind of pictures memorized of what they are. That was section 1.3, or parent function section. Okay, so what's our transformation? What's changed from what our traditional parent function is? Well, this says x squared minus 1. This minus 1 is very different. So what does that minus 1 do? Well, is it inside or outside your function? Well, this is my squared, right? And it's like outside of my squared. It's not being affected by that squared. So this would be considered like outside your parentheses. I could put parentheses around this x here and nothing would change, right? So that -1 is outside, so it's doing something vertically. And since it's minus, right, plus and minus are shifts. So it's shifting vertically, and minus is going to shift it down. So this is a shift down 1. So I'm going to graph this as well. So basically what I'm going to do is I'm going to take this whole graph and just move it down 1. It still goes up forever, so even when you move it down 1, your arrows don't stop earlier, right? Because your arrows never stop. So your arrows should still always go all the way up to the top of your graph. And I'm going to label this as my final function. So this is x squared minus 1. Too far. Let's look at b. Same idea, right? So what is our parent function? Well, h of x equals 2. And we have these absolute value symbols of x minus 1. So that is our absolute value function. So I could spell value. So I'm going to start by just graphing that really quick. And remember, absolute value looks like this V. And then we want to know what transformations are happening, right? Well, our absolute value function is just absolute value of x. So this 2 is new. That 2 is on the outside, so it's doing something vertically, and it's multiplying, so it's like a stretch or a shrink, right? Since it's outside, you don't have to flip it, so it's getting 2 times whatever it is. So this is a vertical stretch. It's a vertical stretch by 2. So I'm going to pause there, and I'm actually going to draw that piece of my transformation, right? So again, I can do it in these pieces. So basically, this is stretching up faster. Okay, so it's going to rise up faster. Then I have this -1. This -1 is inside, so something's happening horizontally, right? Plus or minus is a shift, so it's a horizontal shift. Opposite, so it's going positive, meaning right 1. So now, when I go back to my graph, I'm going to use my purple function and move it right 1, right? So I do each transformation, And the most recent one is what I do the next transformation to. I'm going to put that this is 1. And basically all these points are moving over 1. And so our red function is actually our h of x. That's our final one. Always good to label your final answer in these, right? Because I do want to see like all your pieces of your transformation, but I also want to make sure we know what the final one is. All right, let's look at C. K of x equals -2 square root x plus 1 plus 3. So we have our square root function here. So that's our parent. So I'm going to graph that parent function. Square root kind of looks like that. So then what's happening here? Now the biggest thing to remember is that when you see something like -2, we read that number as -2, and we read -2 as its own number. But what's really happening is this negative and the 2 are affecting your graph in 2 different ways. So we need to read them as 2 separate things. So the first thing we have is that negative. So that's that negative outside of our function, so it's vertical. Again, negatives reflects. And we're going to reflect over the x-axis. Then we can read the 2, and like we just saw in the previous problem, that is a vertical stretch. Oh, I should graph that. Okay. Okay, it's a vertical stretch by 2. Oh my gosh. So let's graph both of these things. Should be doing one at a time. So I'm going to reflect it over the x-axis. So basically, again, it flips down. There's my new function. And then I'm going to stretch it by 2. So that means, again, everything gets 2 times further away from your x-axis. So it got stretched, and since it was already below the x-axis, it got further away, so it got more below. If I was stretching something above the x-axis, it would get higher, right? So it's always away from the x-axis when you're vertically stretching. What's the next thing that's happening? Well, I have this plus 1. That plus 1 is inside, so something's happening, again, horizontally. So I'm going to flip it. So it's shift left 1. So again, I'm going to graph that. So my starting point's always been here. So I'm just going to move my starting point over 1. And to the best of my ability, draw the same shape. Again, I'm not going to be like super picky. I know like it's difficult on the computer or on your screen anyway. So as long as I get the idea that you are shifting it and you know like you're keeping the shape the same, that's fine. But again, this arrow keeps continuing. So like even if you want to think about the arrow being shifted over 1, you then have to continue it more. So your arrows never stop. And then the final thing we have is this plus 3. It is outside, so something's happening vertically, and it doesn't flip. So it's going to shift up 3. So my starting point is now right here, but I'm going to move it up 1, 2, 3. All right, so my starting point's now going to be right there. And I'm going to try and keep the same shape. Okay, so again, this function here is my k of x. Then the next thing we're going to look at, so we looked at graphs. So now we're going to look at numerically. So numerically is like tables. Okay. So this is a numeric representation of f of x. Again, that just means like this is my x value and this is my y value for each of these. So you can think of it being as like the point -4, 5, the point -2, 1, 0, 6, 2, 2, 4, 7. Okay. So I don't actually know what the equation f of x is. I just know that it has these 5 points. It might not have an equation, right? It just might be this set of 5 points. But I can still transform it. So let's look at how we're going to do that. So we have A, we're going to find f of x plus 2. So what does that mean? Really what I'm doing is I'm shifting it up 2, right? This is outside of my function, outside of my parentheses, so it's going to affect our f of x. It's not going to affect our x. So basically our x is going to stay exactly the same, and our f of x is going to get plus 2. So when we take each of our points, right, my x doesn't change at all. My y gets plus 2. And I do that for every single point. -2 doesn't change. 1 gets plus 2. My 0 doesn't change. 6 gets plus 2. Two doesn't change. My 2 gets plus 2. Four doesn't change. My 7 gets plus 2. So then I can like write my final answer. So it's always x. And then we usually give this new function a new name. So the original function up here's name was f. So maybe I'll name this one g, right? So that's my new name for that function. So we have -4. Well, 5 plus 2 is 7. -2, 3, 0, 8, 2, 4, 4, 9. Okay, so again, I just am actually adding is all that's different between those two. So that would be my function that has been shifted up 2. Okay, let's look at part B. Now we have f of 1/2 x. Now we have to be careful. Because this 1/2 is inside our parentheses, and inside of parentheses do weird things, right? So the biggest thing to remember is inside of the parentheses, we do the opposite. Okay, so we want to do the opposite of what's inside our parentheses. And what I mean by that is here we're multiplying by 1/2. We're multiplying x by 1/2. So in our new table, we're going to multiply x by 2, right? Opposite, or think of it as flipping, right? So I'm actually going to do 2x. And now, since nothing is happening outside of my parentheses, my f of x stays exactly the same. Okay. So in our previous example, A, right, something was happening outside, so our x stayed the same, but our f of x changed. Here, now something's happening inside, so our x is going to change, but our f of x is going to stay exactly the same. So I'm still using those points all the way from the top, but now I'm multiplying my x's by 2. I'm going to do 2 times, my first x value was -4. And then my y value stays exactly the same. And I'm going to do 2 times -2. My y value stays the same. I'm going to do 2 times 0. My y value stays the same. And then I'm going to do 2 times 2. My y value stays the same. I'm going to do 2 times 4. And my value stays the same. So for my f of x, or for my new function, right, I'll call this x, and h of x will be the name of my new function. Well, 2 times -4 is -8 and 5. And I get -4 and 1. 2 times 0 is 0 and 6. 2 times 2 is 4 and 2. And 2 times 4 is 8 and 7. So there is the table representing my new function. Okay, let's look at C, our last one. So we have negative 2 f of x minus 3 plus 4. So we have things happening inside of our function. Right, this x minus 3 is happening inside of our function. And we have things happening outside of our function. Okay? So that means we're going to be changing both our x value and our y value. So again, our x value changes by doing the opposite. So the opposite of subtracting 3 is adding 3. Our y value changes just how it is. So it's going to be negative 2. Okay. Now, I don't care about putting the x minus 3 as part of this, right? I already have that taken care of in the top, right? So I don't need to put anything with the x minus 3 here. That's just your f of x, okay? This x minus 3 is part of our x value, not changing our y value. So again, I'm basically going to change it in these ways. So I'm going to take my first number, which is negative 4, plus 3. And then I have negative 2. My first y value was 5. Plus 4. And I'm going to do that for every single part, right? So then I have negative 2 plus 3. Negative 2 times 1 plus 4. And then I have 0. Plus 3. And I have negative 2 times my y value was 6. Plus 4. And then I have 2. And 3. And for my y value, I have negative 2. My y value was 2. Plus 4. And finally, I have 4 plus 3. And I have negative 2. And my y value was 7. Plus 4. And then I just have to do the work, right? So my new table, x of, I'm going to call my new function q. Why not? You can really choose any letter, doesn't matter. Right, I just have to actually do this work. So negative 4 plus 3 is negative 1. Negative 2 times 4 plus, negative 2 times 5 is negative 10. Plus 4 is negative 6. Negative 2 plus 3 is positive 1. Negative 2 times 1 is negative 2, plus 4 is 2. Zero plus 3 is 3. Negative 2 times 6 is negative 12, plus 4 is negative 8. 2 plus 3 is 5. Negative 2 times 2 is negative 4, and negative 4 plus 4 is 0. 4 plus 3 is 7. Negative 2 times 7 is negative 14, plus 4 is negative 10.